So now we show simple implementation example of this program. Okay, SOARS application start, run here, and then you can look at this one. And then click visual cell. Then here visual shell. And actually, well, by drag and drop, then we can create agent on visual shell. And so this circle means the agent. Well. Okay, as the same way, so we can create a spot by drag and drop. And also we can create a role, agent role, and spot role as the same way. Very simple. And also we can drag and drop our developed program on visual shell. Then you can look at that one, like this. And if you can click agent, then you can edit the structure of agent, like a variable and then so on. And as the same way, if you can click agent role, then you can edit the contents of agent roles. So stage condition and action, like this. And if you click on spot, then you can edit the contents of spot. And as the same way, you can click and edit spot role. And by clicking model icon, then you can set up a simulation time and what variable you are logging. And by clicking a stage icon, then you can set up a stage, create a stage or change the order of stage. Actually, well, for combining a different program developed independently, then we can merge stage. That's very important. Okay, and you can also add any visual icon to agent and spot. So we can run the simulation like this. Okay, now you can easily, make a new agent, new spot, new low agent role, and new spot role like this. And you can click and edit inside that one. Okay, and now start run. Then, okay. So, okay, now simulator have started. Okay, and this is the spot contents and age. Okay, so and average age. Oh, the average is very old. Okay, now animate that one. Our animation is not a real-time animation. Use animated log. Okay, so okay, like this one. Simple. Ooh. Okay, so we can run the simulation. And log, this is the log viewer. And we can run the animator like this. So last part, agent-based modeling by role-oriented approach. So this simple example consists of a 4 stage. And we say this is a shared information pattern. So upload and calculation and download and action. So in this model, so in SOARS programming, agent cannot read and write other agent variable. And also, spot cannot change any agent variable. read and write. Only agent can read and write spot variable. And spot also can read and write other spot variable. That restriction is very, very important. So we need a shared information pattern. Agent have to upload its data by themselves. And also agent have to download the average data by themselves. Without that restriction, interaction become very, very dangerous patterns. So this restriction is actually, well, not so essential for designing a calculation or mutual interaction. That might be useful.
Can the agents upload, download from each other?
No. Upload spot at first. So by using spot, via spot, they can interact with each other. Non-direct interaction among agents. That's the point. And by using stage concept, then we can create a useful modularity on agent interaction, among agent interaction.
So if you want to set up a kind of social network here, you use spot. So we generate a number of spots.
Yes. And actually, we prepare the typical type of library on that one.
Oh,
then you can create that one. Now we are just constructing that kind of library. And design patterns also.
How do you relate an agent to a spot?
How
do you relate an agent to a spot?
relate?
Yeah, do they have a fixed relationship?
Actually, interaction was described by using laws. All law define all interaction. But by using a special type of agent or controlling agent or special type of controlling spot, and we can construct so many complex interaction among agent and spot.
Can we create?
If you want to say an agent is in a particular location.
Okay. Spot denote sometime place, only place, but sometime abstract place for interaction, like a market. Okay, so functional spot have special roles, but special spot maybe sometimes no role, but sometimes need a role for interspot interaction, like these spaces. Okay, so and this is the structure of role. Role consists of stage selection part and condition and execution. Condition and execution part, and you can easily understand. So if and if then structure. But the stage part is a very, very unique part. It looks like our standard additional condition part, but it works like about cause. It defines a causal order. So this stage condition have a special meaning. So stage design is essential. And we treat three types of modularity in SOARS. The one is a modularity by stage decomposition. So that means we divide discrete time space into several stages. That kind of stage decomposition is a very, very essential. And in usual event-driven type simulation, so event handler is very, very difficult to design, and totally all events are ordered on stack. Okay? Interaction, and which is person, and so on. But in SOARS, stage order, causal order is defined only between stage. Okay, so and in each agent and spot of one stage can be changeable in its execution. So that's the point.
So when you mention tick delta t, it means
tick means discrete time.
So
one step.
So basically, initial states, main stages, and
okay. Initial state only one time, and start main stage stage 1, stage 2, stage 3, stage 4, and go back to and next tick, and next tick, and next tick, and next tick, and ending calculating something for terminal
So
stage.
the whole thing is executed in one tick.
Yeah.
And then move to the next one will be one tick.
Yes,
Okay.
yes, yes.
Okay, yeah.
And the modularity by role inheritance is also important to construct a realistic, so complex agent activity. But actually, it is easy to understand. It looks like, so class inheritance. But in our approach, so class and our concept of role is a bit different from class. Role can be defined without agent. So we can change the agent. So activate the agent is a very, very important concept. This is the third concept of our modularity of SOARS programming. So sometimes student role exists. And the student role, if this student role, so agent that have a student role are infected, then he can change the role to the patient role and go back to student role. And he graduated school, then he can change the role to worker role. Okay? That kind of change can be defined. It looks like a real world. Actually, SOARS concept, so many SOARS concepts coming from realistic organizational activity. Well, actually, in our usual organization, we are organizing complexity by using law. And this type of stage order is realistic, actually used in our organization. Like let's think about our accounting process. Okay, now it's time to close, and it's time to calculate, and total balance, and now calculate the balance sheet and next term. So that kind of complexity management style is actually used in realistic organization. So we abstracted that concept inside agent-based model.
Can we have more than one role in one stage? In one main stage.
One stage.
One main stage. Because in main stage we can have a number of stages, right?
Yeah. Number of stages. Yeah. And in that stage, we can change the role.
Yeah, within one tick. So it means within one simulation tick, I can execute two different roles.
One tick.
Yeah, in one tick.
One tick.
For one agent, one tick, one agent.
Okay, maybe can changeable. Changeable, but depend on situation. Okay, depend on situation. We can use activate role command. Then activate another role.
Just assume this one is, say, for example, the agent is a broker. Because at the same time, the agent will act as a seller and a consumer at the same time.
Actually, it might be possible. So, role-oriented programming style is our new concept and original concept. How to make a module for dynamic interaction among many agents. It's very important for construct a big model. Stage gives a solution. It's in our opinion. So, thank you for your attention. Okay, it's the end of my introduction. And next turn to